Hello, welcome to the implicit differentiation video. Now we have find dy dx when that happens. Now we don't have y given explicitly in terms of x, therefore we use implicit differentiation. Now with implicit differentiation, it's kind of awkward at first because you see dy dx is popping up left, right, and center in the equation. When you're accustomed to it popping up only in the corner, so it might get a little bit confusing initially, but then you realize just some simple manipulation, and just after the dy dx pop up wherever they want to pop up, I just make dy dx the subject of the formula by grouping all them together, then factorizing, and I am finished. Now example 1, I have that. So step 1, always just differentiate both sides with respect to x. Now common error, you say 3x squared plus 3y to the second power minus 3x times 2y equals 0. No. The reason why you can't just differentiate the y's as if it was just an x, reason being because y is not just an x, y is a function of x. And remember, y is the only letter we are ever going to call a function of x. You're never going to be asked to differentiate any other variable with respect to x except this y, because y is a function of x. Anyways, good. So let's look at the right way to differentiate. So we go from here, look there. So x to the third power becomes 3x squared. Y to the third power, since y is a function of x, then we have 3 times the function of x to the second power multiplied by the differential of what a function of x. What was the function of x? Y. That is why we have d dx of y. This exact rule, right? Function of x to the n power is n times the function of x to the n minus 1 multiplied by the differential of the function of x. If y happens to be the function of x, then we would just have dy dx landing down here, and that is all this is. You know, this first year math really is very simple, right? Very, very, very simple. Minus, you open bracket, 3x, well, this is a product rule. Why is the product rule? Because you have a function of x here multiplying by another x there. So you have a product rule, right? So you pick one function of x, you write 3x. When differentiate, 2y, y squared, sorry, looking at this was the error. You write back 3x. When differentiate, y squared becomes 2y, 2 times the function of x to the n minus 1 power times differential of the function of x. That's why we have this. Plus, we write back the y squared now. When we differentiate x, we just get 3 equals 0. Because when we differentiate a constant, it is always 0. Now, what was it? Oh, why did I get 3 here and not negative 3, since this is a negative? The reason why, because I factored out this negative sign outside the bracket, so I'm just dealing with 3x y squared. Alright, so that is that. So after that, I remove the brackets and neaten things up. I get 3x times 2y. The negative here is negative 6xy. That is that. Plus, I call this 3y squared. From there, I want to group the dy dx's together so I can make it the subject of the formula. So I throw over this and throw over that, and I have that as my final answer. I factor out it a 3, and that is the end. Nope, wrong. Why is it wrong? Simple mistake. When you are here and you have brackets, our next very common mistake, you can't just remove the bracket and call this first number alone negative, because you have a negative 6xy, and just call this negative. If you didn't notice this error while I was doing it, it means you are very susceptible yourself to making the error. This can't be positive here. When removing a bracket, you always multiply the sign in front of the bracket by whatever is in the bracket, right? So this should be negative. A negative and a positive is a negative. It should be negative. This is what it should be. Negative 3y squared, which would, when it's transposed, that will become positive 3y squared, and you would do it this way. Everything else is completely right. I was just harping on a common sign mistake. All right, now let us look to the next question. Next question says, find dy dx when we have that happening there, that bit of information. All right, so now if you look carefully, you will recognize we have two product rules this time. I have a product rule there and the next one there. Because we have a function of x being multiplied by an x or another function of x, differentiate both sides. You look carefully, let's apply the product rule. 5x cubed becomes 15x squared. Here, what we will do, we have x and a y squared. So we leave the x alone, we differentiate y squared. So a function of x squared is called 2 times the function of x to the 2 minus 1 power multiplied by the differential of the function of x. Plus, now if we write a function of x, we differentiate just the x, we get 1 is equal to the differential of this side, 5x cubed, we leave that alone, we differentiate y to the third power, that becomes 3y squared times dy dx, plus we leave y cubed alone, differentiate 5x cubed, and that is just 15x squared. From there, I just expanded the brackets, I made dy dx the subject of the formula, and I presented my answer. You can pause the video, look through this very slowly, and make sure you understand what is happening. So let me just give you a shot of everything. Good. So that is exactly what is happening. All right, number 4. This one has sign inside of it. And now, in that sign, we have a function of x. We can see a product rule within the sign. That is this. That's what we're looking at there. Wow. So let's do implicit differentiation. Once again, we don't see a y given in terms of x. So we differentiate both sides with respect to x. Next step, look at that. Y sign of a function of x differentiated is cos of the function of x multiplied by the differential of the function of x. When we differentiate the function of x, the function of x of itself is a product rule, right? And now you're going to be tested very thoroughly on these things. Expect things like this one to come, right? You get function of x. The function of x of itself is a product rule, right? So you have 2x squared multiplied by the differential of y to the third power, which is 3y squared, times dy dx, plus you write back y to the third power times 4x. We have this. Differentiate this side of the equation. That's just 9x squared. The 1 will just go to 0, because if you differentiate any constant, you get 0. From there, you can look through. All I did is make dy dx the subject of the formula. I just grouped some like terms. That wasn't even grouping. We only had one dy dx. I made that the subject of the formula, and that is it. Number 5, or I don't know what number is this one. Next, I've been working very long. Next, here this time we have to find the second derivative. Hey, focus. The second derivative we have to find now. When s is equal to 4x squared plus 5y squared. No, sorry, not an S. And 5 is equal to 5 is equal to 4x squared plus 5y squared. So step 1, we differentiate both sides, right? And now the 5 would go to 0. When we differentiate 4x squared is 8x squared, 5y squared, 10y times dy dx. So dy dx is just negative 4x times 5y. That's the first derivative. When finding the second derivative, we know the second derivative is just the first derivative differentiated one more time. So here we have an example. So we differentiate both sides of the previous equation by x once again to get a second derivative, of course. Now I factored out the negative 4 over 5. You could have left it in and consider 5y as being the denominator in the fraction, or you could have factored it out, same answer you would get. Now I'm going to introduce a next rule. Whenever this will be quotient rule here. We have to differentiate this because we have a function of x at the bottom and x at the top. From now, every time you have to use quotient rule, I always want to see this formula. If you don't put this formula and you get it wrong, I will mark you very harshly, because people are making mistakes without using this formula. So I want to see the formula. Use the formula and make a mistake, I'll be more lenient in marking. Alright? Alright, so with this, the u would be x and the v would be y. So it is v squared at the top. You put the v, differentiate the x, and it turns to 1 minus, you put the x, you differentiate the v, which is y, you just get dy dx, and the bottom is v squared, which is just y squared. Now in the example in class, we have substituted values for dy dx because we analyze a value at a particular point, right, on the function, right? But here we're leaving the entire dy dx in the equation, no substitutions of an exact point. So this time the entire negative 4x over 5y we would put in our equation. We defined dy dx as being this. Now this is an ugly looking fraction here, so I will multiply everything by 5y at the top and the bottom. So 5y becomes 5y squared. This 5y cancels out, and the bottom of 5y multiplied by what was already y squared now becomes 5y cubed. And this is our answer. Dy squared d squared y over dx squared is simply that. Right, so please note these examples. Please look at the videos. Thank you very much for watching. I wish you excellent success not only in math but in all your subjects. Bye bye.